Welcome back, team. Today, we are unpacking the unsung heroes of generative AI, embedding models. We'll explore the critical trade-offs, how to select the right model, and the mechanics of fine-tuning them for your enterprise domains. Let's get started. To kick things off, let's establish what an embedding model actually does. Historically, we represented text using sparse vectors, like bag of words or TF-IDF, which only tracked word frequencies and lacked semantic understanding. Embedding models changed the game. They compress text into dense vectors-long arrays of real numbers. This allows computers to understand the context and relationships between words, calculating similarities mathematically. It is the foundational layer that powers modern semantic search and retrieval-augmented generation. Looking at this diagram, you see the journey of raw text. It enters the embedding model and emerges as a dense vector. In high-dimensional space, sentences with similar meanings map to points that are physically close to one another, enabling instantaneous semantic similarity search. In system architecture, there are no perfect solutions, only trade-offs. The first major trade-off in embedding models is dimensionality. A model outputting 1,536 dimensions captures deep semantic nuance, but storing millions of these vectors quickly inflates your cloud storage and RAM costs. Second is the context window. A model that embeds a massive 8K token document might lose the specific meaning of a single crucial sentence buried inside. Finally, deciding between a proprietary API or hosting an open-source model involves balancing operational ease against data privacy, latency, and recurring token costs. Remember, you cannot mix embeddings from different models. Once you pick an architecture, you are committed. This tree structure highlights our three primary trade-offs. Expanding dimensions pits accuracy against memory usage. Extending context pits information breadth against pinpoint precision. And choosing where to host pits strict data privacy against the heavy lifting of maintaining MLOps infrastructure. How do you choose the right model? Do not just blindly pick the most famous API. As senior engineers, we consult the MTB leaderboard, the massive text embedding benchmark. When selecting, scrutinize the retrieval average score, which indicates how well the model ranks relevant documents. Pay close attention to the model size and embedding dimensions. A 3 billion parameter embedder might top the charts, but it will decimate your latency budget. Finally, always account for domain requirements. If your corpus is highly technical, multilingual, or specialized, a smaller domain-specific model will often outperform a massive generalist model. Here is our selection decision tree. We start by asking if our data requires a specific domain model. From there, we evaluate our latency and storage constraints. If strict, we filter for models with fewer than 512 dimensions. If flexible, we scale up to high-dimensional state-of-the-art models for maximum semantic capture. Let's dive into the implementation. Frameworks like LangChain provide standardized interfaces for embedding models, making it easy to swap them out during testing. The critical architectural practice here is batching. During your ingestion pipeline, never embed chunks in a simple loop. Use the embed documents method to pass large arrays of text to the model simultaneously. This drastically reduces network overhead if using an API and maximizes GPU utilization if running locally. Conversely, at runtime, use the embed query method for the user's singular prompt. The output will be a nested array of floating point numbers ready for vector storage. This class diagram demonstrates the core embedding interface. Both OpenAI and Hugging Face models inherit from the same base class, ensuring you always have access to the optimized embed documents for bulk indexing and embed query for real-time user searches. Now for the deep dive, fine-tuning. Even top-tier embedders can fail on proprietary company acronyms or niche medical jargon. To fix this, we fine-tune the embedder using contrastive learning. We train the model using pairs of data in anchor text and a positive match. We use a sophisticated loss function called multiple negatives ranking loss, or InfoNC. This function mathematically pulls the anchor and positive match closer together in the vector space, while simultaneously pushing the anchor away from all other negative examples in the training batch. Best of all, fine-tuning a 30 million parameter embedder is exceptionally fast and cheap, yielding massive ROI for your RAG pipeline. This diagram visualizes contrastive learning. In the center, we have our anchor query. The training process dynamically pulls the green positive document closer in the vector space, while creating repulsive mathematical forces that push the red negative documents far away. Let's examine a powerful, real-time use case, the enterprise semantic router. Imagine a unified corporate chatbot that needs to access entirely separate databases for legal, HR, and IT. Sending every query to an LLM to decide the route is slow and expensive. Instead, we use our embedding model. We pre-embed 50 typical questions for each department. At runtime, we instantly embed the user's incoming query and calculate the cosine similarity against our pre-embedded references. If the query is closest to the HR cluster, we route the system to the HR RAG pipeline. This executes in milliseconds, costs fractions of a penny, and creates a highly resilient routing layer. Trace the execution path here. The user query hits the embedder, turning into a vector. The semantic router performs rapid cosine similarity checks. Based on the highest similarity threshold, the query seamlessly branches to the correct isolated database IT, HR, or legal. As your enterprise scales to billions of embeddings, the storage costs will threaten the project. We mitigate this using two cutting-edge techniques. First is quantization, reducing vector precision from 32-bit floats to 8-bit integers, or even binary. This shrinks memory costs by up to 32 times while retaining incredible accuracy. Second is matryoshka representation learning. Like nesting dolls, these models are trained to pack the most critical semantic meaning into the very first dimensions of the vector. This means you can dynamically truncate an expensive 1024-dimension vector down to 256 dimensions right before storing it, drastically cutting costs with negligible performance loss. Master these trade-offs, and you master enterprise AI. Please invite learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Our final diagram illustrates matryoshka truncation. We start with a massive, expensive 1024-dimension vector. Because the model front-loads the semantic value, we can safely slice the array down to 512 or 256 dimensions, feeding directly into massive cost savings without losing the core meaning.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now the third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepared for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.